name is Monozat and today I'm presenting my database development project system. It's called Secure Library Management System. Uh, this project focuses on designing and implementing a full functional relational database system for managing activities in a secondary school library. So the goal of this system is to organize, store, and manage all library operations efficiently while reducing redundancy and ensuring data integrity. Uh, uh, the system library management system uh, manages students, librarians, authors, books, borrowing transaction, fines for right return. This ensures proper monitoring of library resources and improve accountability. Well, here there are three main users. First is student who borrow and return books. The second is librarians who manage borrowing transaction, and school administration who monitor reports and fines. Uh, here with database entity. To design the system, I identified six main entities. The first of all is student, next is librarian, author, book, borrow, and fine. Each entity represents a reward object, separating them into different tables, reduced redundancy, and improved database normalization. Now, let's talk about normalization to sad normal form. Uh, what we call normalization? Normalization is a process of reducing data redundancy, duplication of data, and increase data integrity. Now I will explain how I normalize the database to sad normal form. Here I have an normalized form. Here student ID stating name, book 1, book 2, borrow date 1, borrow date 2. As this causes the repeating group and multiple value in one low redundance, data redundance. Here on the first normal form, I remove the repeating group. Now each row contain one student here, one student, and one book, and one borrow date. This ensures atomic value. On the second normal form, the problem was partial dependence. Student name depends only on student ID, and book title depends only on book ID. Yes, so I separate the table into student, book, and the borrow. This borrow we have here, it become its own tables. Now there is no partial dependence. As you see, we have student, book, student ID, student name, book ID, book title, student ID, book ID, broad date. This is a foreign key. It's primary key in student ID, and this is a foreign key from book with attribute called book ID. Let's talk about the third normal form. there was a transitive dependence. Author name depends on author ID. So I created the separate author table. Now the database has no repeating group, no partial dependence, no transitive dependence. uh, as you see, your name depends on what item it is. You have a notable, a student, a variant, author, book, bolo, fine. Yes. Therefore, it is a full normalized to CNF. I mean, it's real normal form. Let's continue on the integration diagram. In the ARD integration diagram, the relationship are one student can have many bolo records. One book can appear in many bolo records. One librarian manages many bolo transactions. One author writes many books, and one bolo may generate one fine. Uh, Primary key are underlined and foreign key are clearly indicated by dash dash line, and cardinality shows one too many relationship, like one dot dot, like this. Yes. this this structure ensure referential integrity. um, we talk about data dictionary. As you see, this is the yeah, this area here. Then if you need it, you can put a relationship that is textured like a diamond here to join this and this, and here join this and this, and here to join borrow and find, here join book and borrow, join book and authors. That's cool, but I didn't use it because we have uh, to a small time to finish work. So let's talk about data dictionary. Each table includes field name, data type, pool size, constraint, and description. Yeah, this is what we call description. This is what we call data type. Uh, Int, vertical, size. You can give it the size you need. A constraint, primary key, not now, foreign key, yes, and so on. Unique tariffs. For example, here on student table include student ID int as uh, primary key PK yes, with auto increment. First name and last name as non as and the classes. Some forms and class field distribution, unique ID, first name, last name, student class, phone number, and so on. All constants ensure data consistency and be validity. Let's dive in on the all tables. Let's talk about database implementation. Uh, Database implementation. Uh, on this, I implemented the database using SQL. First, it's create table. I mean, create database name called school library. This use library because I have used the CMD. You must select the database you are going to use. Here, I did the command and with yes, yeah, I created the base school library. This is what I created. Use school that is query above. Uh, Then I created the old table using primary key, foreign key, auto increment, data type, and constraint. Uh, the foreign key constraint enforce relationship between tables. As you see the table I created that I was talking not null, not null. You see the constraint. You see the don't remain. Uh, here I can find foreign key. Where is it? Foreign key will come below especially as here. Return date. Foreign key student ID find student ID. Foreign key book ID finds book ID. Foreign key librarian ID finds librarian. Foreign key have I was saying and this. Let's talk about the sample that I have used. I inserted this sample data including three students, one librarian, three authors, three books, borrow, translation, and finding fault. Yeah, this is a sample for inserting the student, the queries inside the student, first name, last name, class, from that is the attribute we started on our entity. Yeah, it's a value. The first name is John, the last name is Joy, price is near 3, phone number is 06, and this and this. Uh, the second, the second floor. Yeah, the second, the third data. Then started. That is that also. That is that also. And this, yeah, it's straight for queries. We talk about SQL queries. uh, we talk about basic select. I wrote this SQL query divided into categories. First of all, the basic select to retrieve records. It's simple. Select all from student. Select the first name last name from student. That is a solution. Here on the first query, state of student, we select uh, that's all students. All students, that's all data stored in student table. And and here select first name, last name from student to select first and last name of all students. All data stored in each student table. And so on. So we read order bar, order S, and let me show this by using order. And this settle from book where category equal literature to select or where category is a category is an attribute where the attribute equal literature or literature as a category will display. And this order by published year equal descending. We we look for published year is also an attribute and give you displayed by descending from largest to the lowest. Then select row from student require me to do we select only first two rows. Second is aggregate function. Count, sum, average, max, mean, group by. That is, yeah, select all from select count all from books to count the books. Here is what we found. Select count all from books. Three have three books. No. Select some amount from fine. they will give you the total of some uh, from table called find or entity in the attribute called select average amount from find to show you the average of amount, and this will show minimum and maximum, and here it will count group by grouping category. Yes, if literature is a 2, it will show you 2. If literature is 6, 6 it will show 6. If drum is 1, it will show 1. If drum is 2, it will show 2. If the drum is second, and this and more, yeah, to combine, I think that is same, and count it and display, and take other same, count it and display. That is the next is filtering. Filtering using where, between, in, like. Here there is selector from student where class senior 3, and the phone is not it will give you this where the phone number is ordinary and is class senior 3. If there is more, it will display. But on my table, in the sample data we have input that's really only student. That's why on one is classes senior 3 at this this the first condition here, classical senior 3, and the second condition must be true, not one true or other false. No, all must be true. And this is the next solution. Sector block where publish the year between 2000 and 1024. Then book title display. This is what we display. Selected from books player category in drama literature. That is what we display in drama literature. It means the category has literature and drama, all things that have that we display. Selected from books where title like the liver to display all things that all all the title has a liver in the middle, the best. We have the join to combine multiple tables such as student borrow or borrow with books or others. Here it will select when you use this example for this. Select the student name, video title from borrowed. This means student is being his book. But join here student is on BR the student ID is student ID to rejoin the student name and title in the box. Call student name, first name, and the title. That's what you're going to join from bottle. Yes, because this and this student table and book table has some connection, and also the correlation. Let's dive on subqueries. Subqueries to perform nested queries. Access queries. Select this example selector from student where student ID. Yes, subquery this and this. Maybe two queries one, and this you can read the next queries. Here let's dive on the solution. Here selector from student where student ID in select student ID from below to display display the ID, the name, the table of students. Yes, table of students that have been that have been that have a mention in it. Apollo as let's type that is also the solution. Let's talk about the update and modification. Update find set payment status equal paid where find equal find ID equal 1. Till we update define table set payment status equal paid. Status the payment status will become paid, but on where find ID equal 1. When you check here um, on this display, the find ID equal 1, payment status is unpaid, but here when you use this query, we found 1 will be paid. Retreat from find where amount equals 0. If there is some some laws or some that has amount 0, here example this here 500, and press 0. This it will treat this first law if we change bad. And also here, so to find, see, I was showing you that things that change and paid and paid become paid. Here we're going to advance the query using having group by and nested subqueries. Those queries demonstrate full understanding of SQL operation. Okay, select student ID count all from borrow to buy student ID having count. It means more work, many queries in one. I can say 21. Yeah. Select student ID count all from borrow. Group by student ID having count. Sorry. That filter from find order by amount is any limit to too bad. Uh, order by descending from largest to the lowest. This is the second. Yeah. Second before select enemy sector from student where student ID in select student ID from borrow where this is what you call next to the queries. Yes, next to the queries or subqueries. Student ID name class and form, that is face. Yes, select contact. So this name, rest name, other form, other name from a student, then to this path name, full name and last name, but name in the one. This is the first name and this is the last name, but to join that full name and display that, I think that is the presentation. This design use the data to ensure that integrity supports scalability, allows reporting, and flows that number from standard can be expanded in the future by adding book copies, payment record reservation system. As a conclusion, the school library management system successfully demonstrate proper database design, normalization tools, normal form, integration diagram modeling, data dictionary creation, SQL implementation, and the query writing skills. this project reflects real world database development practice and can be implemented in any actual school environment. Thank you for listening. I'm ready to answer any question. Bye bye.